The divergence of a vector field gives us information about the change in density at a particular point. In order to calculate the divergence of a vector field in either 2 dimensions or 3 dimensions, we will again need to use this del operator, which in 2 dimensions looks like partial with respect to x, partial with respect to y, and in 3 dimensions we simply tack on the partial with respect to z. To calculate the curl of a vector field, we took this del operator and we crossed it with cap f, but for that divergence, we'll take this del operator and we'll dot it with cap f. Remember that the dot product of two vectors yields a scalar quantity, and so when we calculate the divergence of the vector field, we get a scalar, not a vector. If that scalar quantity turns out to be a positive number, we'll see that we are experiencing a decrease in density at that domain element. If that scalar quantity turns out to be a negative number at the domain element, then we'll see an increase in density. And this is true for both 2-dimensional and 3-dimensional vector fields. So let's take a look at how that might appear in a vector field if the divergence of f evaluated at a particular domain element is positive. We can think about the vectors that are flowing into that point as being smaller than the ones that are flowing away. We've got a higher velocity coming out of the point than going in, and this is going to result in a decrease in density at that point. If this were a fluid, we could think about it as flowing away from that point. If the divergence of that vector field evaluated at a particular point turns out to be negative, in this situation we'll see an increase in density. The vectors flowing into that point are greater than the ones that are flowing out. We have more going in than going out, and we can think about that flow as going into that point. If the density is increasing and more of the flow is going in than coming out, this is what we call a sink. If the density is decreasing and more is coming out than going in, this is what we call a source. When the divergence is equal to 0, there's no change in the density. And if we were to take the divergence of the vector field that is the curl of that vector field, we'll always get the scalar quantity that is 0.